At the heart of our solar system lies a massive, glowing star that provides light, heat, and energy to everything in its reach. This radiant ball of energy is our sun. It's more than just a source of daylight. It's a dynamic force that influences everything from the weather to the very air we breathe. Today, we'll uncover the science behind this burning powerhouse and explore why it's so crucial to life on Earth. The sun is a star, but what exactly does that mean? Unlike the solid objects we're familiar with, the sun is not made of rock or metal. It's made up mostly of hot gases, primarily hydrogen, about 75%, and helium, around 24%. The remaining 1% includes heavier elements like oxygen, carbon, neon, and iron. It may look solid from afar, but the sun is actually a gigantic ball of plasma, a state of matter where electrons are stripped away from atoms, creating a charged, energetic environment. This plasma is constantly in motion, and its behavior is governed by complex forces of magnetism and heat. Now, let's talk about size. The sun is truly enormous. It has a diameter of about 1.4 million kilometers, which is roughly 109 times larger than the Earth. Imagine placing 1.3 million Earths inside the sun. Yes, that's how vast it is. And its mass? The sun is so massive that it accounts for a staggering 99.86% of the total mass of our entire solar system. Every planet, moon, asteroid, and comet combined makes up just 0.14% of the solar system's mass. The sun dominates everything around it, influencing the orbits and motions of the planets. The sun's incredible energy comes from the process of nuclear fusion. Inside its core, temperatures soar to about 15 million degrees Celsius, 27 million degrees Fahrenheit, and the pressure is so intense that hydrogen atoms are forced to collide. When they collide, they fuse together to form helium, releasing a tremendous amount of energy in the form of light and heat. This energy is so powerful that it can take thousands of years to travel from the core to the surface. The energy travels through a dense radiative zone where it slowly disperses outward through radiation before reaching the outer layers of the sun. Once this energy reaches the outer layers, it radiates out as visible light and other forms of electromagnetic radiation, including ultraviolet light, infrared, and even X-rays. This light travels through space at a speed of about 300,000 kilometers per second and reaches Earth in just 8 minutes. The sun is made up of multiple layers, each with its own distinct properties. The innermost part is the core, where the sun's energy is generated. Beyond that is the radiative zone, where energy moves outward through radiation. As the energy travels through this dense zone, it can take hundreds of thousands of years to reach the next layer. Above the radiative zone is the convective zone. In this layer, heat is transferred through convection currents, much like boiling water in a pot. These currents bring the sun's energy from deeper layers to the surface, creating huge gas bubbles that rise and fall, like solar storms. Then we have the photosphere, which is the sun's visible surface. This is where the light we see originates. The temperature here is about 5,500 degrees Celsius, 9,932 degrees Fahrenheit, and it radiates the light we see as sunlight. Next is the chromosphere, a thin layer of gas just above the photosphere. It's most visible during a solar eclipse and glows red due to the temperature and ionized gases. Finally, there's the corona, the sun's outermost layer. It's surprisingly much hotter than the surface with temperatures reaching around 2 million degrees Celsius, 3.6 million degrees Fahrenheit. The reason for this remains a mystery, but scientists believe it's due to magnetic forces at play. The sun's power goes beyond just providing light. It has a profound effect on Earth's climate, weather patterns, and even our biology. Solar radiation drives the Earth's weather systems from winds to ocean currents. It also fuels the process of photosynthesis, which is essential for plant life and in turn, the oxygen we breathe. One of the most interesting effects the sun has on Earth is the creation of the auroras. The sun constantly emits a stream of charged particles known as the solar wind. When these particles interact with Earth's magnetic field, they create stunning light displays in the polar regions. These auroras are the result of high-energy particles colliding with gases in the Earth's atmosphere, causing them to glow. But not all solar effects are benign. Sometimes the sun releases bursts of energy known as solar flares or coronal mass ejections, CMEs. These events can send enormous bursts of radiation and charged particles into space, potentially interfering with satellites, communications, and even power grids on Earth. Like all stars, the sun has a life cycle. It's currently in the main sequence phase, during which it steadily fuses hydrogen into helium. This phase has lasted for about 4.6 billion years and will continue for another 5 billion years. Once it exhausts its hydrogen fuel, the sun will begin to expand into a red giant. As a red giant, the sun will swell up, potentially engulfing the inner planets, including Mercury, Venus, and Earth. Afterward, the sun will shed its outer layers, creating a beautiful nebula of gas and dust. The core will collapse into a dense, small object known as a white dwarf, which will eventually cool down and fade away. The sun is more than just the source of daylight. It's the force that drives the solar system, affecting the climate, weather, and even life itself on Earth. It is an incredible, powerful, and dynamic star. Although it might seem eternal, it too will one day meet its end, but not for billions of years. Until then, we continue to marvel at its power and mysteries. Subscribe to learn more about the wonders of our universe.